This is my project for the ultrasound simulation using Kwave for optimal IBIS device frequencies. So firstly, the disease we are going to be combating is atherosclerosis, which is a buildup of fats and cholesterol between the intima and adventitia. This causes narrowing of blood vessels, bursts, and blood clots. This can lead to peripheral or coronary artery disease, which will create heart attacks or heart failures, chronic kidney disease, or even tissue death. And so the best device and our main focus for our project is going to be the IBIS device, which stands for intravascular ultrasound. These are going to be mainly mechanical for our project, which means that it physically rotates the ultrasound catheter. These devices release ultrasound waves, which bounce back from the material it hits onto the catheter. And so resolution and penetration depth are going to be inversely correlated, which means if the resolution is going to be higher for a frequency, then the penetration depth will be lower, and vice versa. And so the problem for single frequency IBIS devices, which are what is currently being used, is the clarity of images and the need to replace single frequency IBIS devices with different frequencies. As you can see, for the 30 megahertz and the 80 megahertz, these have very different clarities in terms of image quality. And so with a multi-frequency IBIS device, as you can see on the right, it can create a much more clear image for both penetration depth and for resolution. So multi-frequency devices. Currently, there are some problems such as the costs of testing because of the need to create physical environments to test in, as well as uncertain optimal frequencies. As you can see in this quote, there needs to be a higher frequency for the IBIS device transducer, as well as a lower frequency. And because of how large these ranges are for different scenarios, there's a need to be able to find optimal frequencies without the high cost of repeated testing. And this is where our project comes in, which we use Kwave. This is a simulated ultrasound environment and uses time domain acoustic and ultrasound simulations in complex and tissue realistic media. This basically means that we can simulate an environment virtually with frequencies and tissue. Currently, we have some findings. As you can see on the right, the blue little bars represent plaques, and you can see on the far right are images. We can see that preliminary findings show the work of the simulation, and we know that high frequencies have higher detail but less penetration depth, and lower frequencies have low detail and deeper penetration depth. And for a conclusion, it shows that a simulated environment for the multi-frequency IBIS device has not been explored properly, and by continuing our work, engineers have a frequency range to focus on after they use our program, and can have more resources to work with and more time to focus on physical aspects. And for our future work, we would like to create a program that is user-friendly for multi-frequency IBIS devices. Thank you for listening.